related to the petroleum. So in today's class we'll be talking about the petroleum. Its introduction will be there, and the history will be there. History is very important. Along with that, the reservoir rocks. Most of you if you have attended my previous classes, then you might know that rocks could be of several types, so among which sedimentary rocks are good for reservoir. So these three things I will try to cover in today's class. So let's talk about petroleum. So what do you mean by petroleum? The word, basically the petroleum originates from the Latin word, and the word is petra and oleum. So petra means rock and oleum means oil. It's called the rock oil, or simply we call the मिट्टी का तेल. हिंदी में क्या बोलते हैं मिट्टी का तेल, केरोसिन को? So it means the rock oil or mineral oil, and in ordinary sense the nature of hydrocarbon, that's the chemical compound of. What do you mean by hydrocarbon? Chemistry people knows that hydrocarbons means it's a chemical compound of hydrogen and carbon. You might have read in your school chemistry, like benzene, toluene. These are the hydrocarbons. So in ordinary sense, natural hydrocarbons are found in a rock, in gaseous or liquid or solid state. So you might ask, you know the gaseous state. Example, any example? Gaseous state petroleum, what it's called? Yes, methane, and we generally see in the LPG cylinders. That's the gaseous state that's the fossil gas we are getting. It's also, petroleum is also, or the diesel or petrol is also called fossil fuel. Why? That will be discussed in your origin chapter. Okay. So gaseous state is also there. Liquid state, you also know that kerosene and oil, or these are the products, or this is the component or constituents of the petroleum, petrol, diesel and all. What is the solid state? So I have mentioned here that the hydrocarbon or the natural hydrocarbon you are receiving, that's are also in a solid state. So what do you mean? Solid state में कब रहता है? So you will be reading in your next chapter, that is the coal bed methane. Okay. So it's generally formed in between the coal layers, and you will find when you will be excavating this, you will find this in a solid state. The methane will be somehow that solidifies. That will be discussed in that chapter, in your next chapter. So what are the uses of petroleum? These things you know already. So half of the or more than half of the fuel energy of the world comes from the petroleum. Most of the modern transport system are using petroleum. You know that oil is basically the major source for industrial power or synthetic material. You might know this also. The synthetic materials like nylon, like rayon and others generally comes from the petroleum. And in the cold countries, room heating is provided by a system which produces heating of water by burning oil. Villages में वो डिब्बा रहता है केरोसिन वाला. So there is and other byproducts are asphalt, bitumen, pitch. So asphalt, bitumen and pitch, these are used in your used as road metals or road constituents. You know that, right? So there are huge applications of petroleum, and the uses of oil are innumerable. So in the ancient days, people in the South African country like Baku, and that villages they uses petroleum or this crude oil basically to cure some skin problem. Okay, and that the main constituent of that ointment was petroleum. Since the dawn of the civilization, people has been making petroleum and petroleum products, and this crude oil and gas come to the surface of the earth through fissures and form a seepages. तुम किसी को मालूम है कि इंडिया में कैसे पेट्रोलियम डिस्कवर किया था ड्यूरिंग द ब्रिटिश पीरियड? How petroleum discovered in Assam? Okay, did anyone know? That's an interesting story. So people first, the Britishers, they basically found petroleum in the footprints or in the footprints of an elephant. हाथी के पैर में वो क्रूड ऑयल लगा रहता था. So उसके बाद से they established a company still going, and it's under is a you can see it's a PSU, okay, public sector. It's called Oil India Limited. So it's in Assam. In Assam, they to be specific, in Dibrugarh, Assam, they basically found that crude oil. But before that, in other places, people already found oil, and they were reaching. And that time, the crude oil was easily available in the upper surface. Now it's not. So what we do? We use several techniques for exploration of oil and gas. Okay, and the exploration or the search or the survey is done by primarily by geology. Sorry, means the primary objective, the geologist will look into the matters where it can be some oil and gas zone. Is the exploration or the prospecting is done by geophysicist. Okay. No, GSI only deals about the geological aspect, mineralogical aspect. It's done by the ONGC. Okay, so I'm a geophysicist mainly, and it's our job to find out to explore where the oil and gas is, what is the quality, is it profitable or not. Okay, so exploration part will be discussed also in briefly after completing the basics. Okay, so one by one हम लोग कैसे पढ़ते चलेंगे. Now, so the history of the petroleum start at 6000 BC. Okay, people don't know it's a crude oil, but they used for some firework, they used for some other work, and sometimes some historian like petroleum was mentioned by Aristotle, Pliny, and other ancient Greek and Roman authors. Sometimes someone I forgot that Marco Polo. When Marco Polo was going to China, then he visited the Baku village, and he was passing through this Baku village. So Marco Polo visited and went to the China to meet Kublai Khan. So in his way, he found some places where people were using petroleum. They don't know how to explore that one, how to excavate that one. That time it was easily available. Still at some places you might have petroleum easily available, but अगर ऊपर में कोई कुछ रहा होगा अभी तक तो निकाल ही लिया होगा, इतना यूज होता है इसका. Bible is itself recorded this petroleum or the uses of the petroleum, and the first petroleum machinery or first oil is called the oil. हिंदी में क्या बोलते हैं ना, तेल की खनी है ना, क्या बोलते हैं उसको, तेल का कुआं. हाँ, सऊदी अरब में कि मेरे पास तो तेल का कुआं है इतना, ये ऐसा बोलते हैं ना कि मुहावरा देते हैं. सो फर्स्ट ऑयल वाज dug in 1859 by some Cornell. Okay, so Cornell Drake, not the rapper. Okay, so Drake was the first one who dug the well, but इसका कोई फायदा नहीं हुआ, ये गरीब ही मर गया. So that's the basic history of the petroleum. To warm up this class, I talked about this. Now let's jump into the main topic, that is your reservoir rocks. So you know that petroleum and natural gas is found basically in varieties of sedimentary rock. What is a sedimentary rock? Who can tell me? Yes, kind of, not gravels, say sediments. Yes, sedimentary rocks are basically formed by sediments. Okay, what happened? The weathering effect of the physical agent like river water or the sea water or glacier or air, they basically erode the existing rock or existing structure, and they create small fragments. That fragments is called sediments, and later the sediment accumulated due to this physical agents effect. Could be water, or suppose let's take an example of water. Okay, so due to water is carrying the sediments and depositing at a basin like structure layer after layer, and it's creating a sedimentary rock after compaction and cementation. I have already discussed this one. So you know that the petroleum and natural gas are basically found within the sedimentary rock. These are the reservoir rock, and these are the mainly sandstone and limestone. if you remember sandstone, limestone. Okay, so these two sedimentary rocks are making about 80% of the reservoir. Okay, and they are extend about 90% of the reservoir, you can say. And clastic and carbonate rock contains more than 90% of the world's raw oil and the reserves. So sandstone is the clastic and this is the carbonate. I will discuss about this. So sandstone and limestone is generally making 90% of the total reservoir. So at first we will be learning the characteristics. First characteristics, what we generally look into the in the reservoir rock, what we generally look, we look for the porosity. Is the porosity is good enough for to be a reservoir, or porosity and permeability. So what do you mean by porosity? Yes, that what amount. So the mathematical formulations. Void volume by bulk volume. Let's say this is the Vd by Vt. Okay, so it's generally expressed in, what's the unit? It's generally expressed in percentage. Okay, so I'll multiply with 100%. Okay, now porosity, I have already talked to you about the primary porosity and secondary porosity. So primary porosity originates during the formation of rock. That's the origin of the nature of origin and nature basically depends on three things. So for the primary porosity, when I am talking about, that means it depends on three things. First one is your depositional environment. What do you mean by depositional environment? It means the deposition of sediments is happening by suppose river water or by glacier or by air. Depending on the environment, the primary porosity will be defined. Now second parameter, it will depend, or the nature of the primary porosity depends on, first depositional environment, second is your compositions of the rock. Okay, and third would be the size and shape of the constituents. Size of shape of the mineral grains. Now let's take to understand this topic. So let's take an example here. Let's take two case studies. Okay, so let's take two case studies. This is case 1 and this is case 2. Okay, so here you are filling these with some beach balls. Beach balls are there. Okay, and this is you are filling with some marbles. We used to play in your childhood that marbles, not marble rock, or small balls, or let's say these are the tennis balls. So these are the footballs and these are the tennis ball you are filling it up. Now tell me, in which case you will have more porosity? In which case you will have more porosity? Case 1, because the gap between these larger grain sizes will be maximum comparing to this one. Okay, so the primary porosity basically depends on the depositional environment, the composition of the rock, and the size and shape. Size and shape meters. Size and shape of the constituent grains of the rock. Now let's talk about another type of porosity, that is called the secondary porosity. I'm denoting primary porosity as phi p and secondary porosity phi s. So what will be the phi s? The secondary porosity originate from the formation of rocks and depend on. So what do you mean by secondary porosity? Primary porosity developed during the origin. Actually Tanmoy is attending this class for the first time, that's why I'm explaining again. And secondary porosity is originated. So primary porosity actually developed during the origin time. Secondary porosity developed later. So what do I mean by that? So it could depend on, or It depends upon the fracturing on the and shattering of the rock. Obviously, the fracturing happened after the formation of the rock. Secondly, primary pores may be enlarged due to the effect of the solution. So some chemical effect will be there, and due to the solution there is a vague kind of structures are developed. Or if there is a limestone in the path of a river or river water, then it may generally create vague like structure. There are several limestone cave you will find in the South Indian side. Okay. Now, due to the deposit of a solution of cement of the pores may be constricted or may be closed. This is happened. This can make enlargement of the pores. Now it can fill up the pore if there is this is the hole and this hole is filled up by some chemical precipitation or cementation. It's quite common. So by this way, it's reducing the void space. So this type of structures is generally called the secondary porosity structure, and our total porosity phi t, that is the total void space divided by total volume, which can be written as, or which will be a summation of phi p plus phi s. Phi p is the primary one, phi s is the secondary porosity. Okay. Now let's discuss this about with respect to reservoir rock. This total porosity, what I have mentioned, this is also called the absolute porosity. And in the study of the reservoir rock, the volume of the interconnected pore spaces is measured also, which is filled up by the recoverable oil and gas, and the ratio of this volume to the total volume is also called the effective porosity. So there is another term that's called the effective porosity, phi effective. That means it's the ratio of the total volume of the rock and interconnected pore spaces. It's also called, this effective porosity is also called, this one is also called interconnected porosity. So it's called the effective porosity, effective or interconnected. So if the interconnected pore spaces, you will be considering only interconnected pore spaces. Divided by Vt. So let's say interconnected pore spaces are V connect divided by Vt. That will be your phi effective. So when I talk about porosity with respect to petroleum, then I will be talking about this also for a particular fluid of viscosity. Okay. So if you didn't get this interconnected pore spaces, suppose there, let's have an example. This is the section, rock section you are seeing. Here this pore space is interconnected with this one, also interconnected with this one, is make a channel. So when I'll be calculating the effective porosity, then for a particular fluid I'll be considering this void space. Okay, so that's called the effective porosity. Now the total porosity of the oil bearing range between 5%. Let's talk about the total porosity, phi t, and it ranges between 5% to 40%. Okay. And generally it for the oil bearing rock, so let's make a table here. Now depending on the porosity, you can also classify the potentiality of oil bearing reservoir rock. So oil bearing potentiality, oil bearing potentiality, okay, and this is porosity, phi t in percentage. So if the porosity is in between 0 to 5, that is less porous, the rock is not you can say it's a low porosity rock type, then your potentiality of having oil in that rock, or that rock is not suitable for reservoir. Now if the porosity is in between 5 to 10%, then you will be seeing is a poor rock to be a reservoir. So these two you might not be considering for reservoir. 10 to 15 you can consider, okay, it could be a good reservoir, but you commercially it will not be suitable. So you have to consider the profit also. So when you will be extracting, or when you will be spending some money, you are expecting some profit. अब 10 to 15% में कितना ही पेट्रोलियम रहेगा. So what you will consider that, okay, it's fair. जब पेट्रोलियम एकदम से ख़त्म हो जाएगा तब we will take this, we will take a while here. But if the petroleum percentage is 15 to 20, that is good enough to go for your excavation, or to go for the extraction of the petroleum. Now if it's greater than 20 to 25% or greater than 25%, you will be seeing it's a very good rock, it's a very good porous rock, and it has a potential to become a good reservoir. If you found a rock whose porosity is like this, then you will go. I'm not talking about the permeability till now. Till now I didn't consider the permeability. I'm representing this with respect to the porosity. So if the porosity is 20 to 25% or greater than 20%, then it should be a good enough, or it will be a good rock to be, or it has the potential, highest potential to become a well bearing rock or well bearing reservoir. But one thing you have seen, that what matters, that's the interconnectivity. पोरोसिटी रहने से कुछ नहीं होता है. You have to store that reservoir or that petroleum in a place. If you want to make a storage, क्या चाहिए उसके लिए? ट्रांसपोर्टेशन सिस्टम अच्छा होना चाहिए. अब किसी एक जगह पे तुम स्टोरेज बना दिए हो और उसमें ट्रक नहीं घुसता है, इफ योर ट्रक इज नॉट रीचिंग देयर एट योर स्टोरेज प्लेस, देन देयर इज नो मीनिंग ऑफ दैट स्टोरेज. ओके, so this storage should have a good transport system. So generally what happen, oil and gases migrates from one place to another. I'll discuss this in your next class. And it's stored at certain place. For that, what matters, if these ports are interconnected, then only you can consider this a good reservoir rock. So to express interconnectivity, we have another parameter. I have already discussed about this in previous classes. That is your permeability. So what does permeability tells us? Permeability tells us how easy a liquid is, the measurement of easiness of a liquid of certain viscosity to pass through one point to another. Formula you have remembered, the Darcy's law. Okay, from there you can have the permeability kappa or K. Okay, now so the property of rock which permits the flow of fluid through its interconnected pores. So interconnectivity is very important, from which you will have the permeability. And this permeability, what I have discussed, that's called the absolute permeability. So the absolute permeability varies considerably in different rock types, but it is independent of nature of the fluid. A rock is considered to be well permeable if there is a easy and speedy flow of fluid in good quantity in a short time. If there is a no flow or negligible amount of flow, then we will be saying is a impermeable. इस टर्म को याद रखना, अभी जब रिजर्वायर कैप पढ़ाऊंगा तो ये काम में आएगा. So when no flow is happening, that's the impermeable layer. So in generally within a rock body or within a rock structure, there are more than one type of fluid will be there. So in many reservoir rocks, water, suppose in the reservoir rocks you will be seeing water, oil and gas. Okay, and this create a mutual interference. So there is another term to define permeability, that's called the effective permeability. Just like the effective porosity, that's the effective permeability, or let's say K effective. So it is defined as the ratio the capacity of the rock to contact a fluid in the presence of other fluid is effective permeability of that particular fluid, suppose water. So the effective permeability of the water is can be expressed as divided by permeability due to the water or in the presence of water divided by the KT. That's called the So that's called the effective permeability. Now there is another term that's called the relative permeability. So relative permeability can be defined as Kr equals to K effective. Effective for whom? Let's say it's for water or gas or petroleum. So in this case I'm considering water, and divided by the total or absolute permeability. So effective permeability, and you are making a ratio with the absolute permeability, that's called the relative permeability, which has no unit. Okay. Now tell me the unit of permeability. Tell me, Darcy. One Darcy. We generally measure permeability when we are talking about rock and others. So we generally measure this in the range of 1 millidarcy or in the range of millidarcy. So we'll be using the millidarcy term. Okay. Now in the reservoir rock, the water, oil and gas fill the pore spaces in different proportion, and the relative permeability of the one fluid in the rock. Are you taking notes or not? Whatever I'm writing, just try to take notes so that okay. So in the reservoir rocks, the water, oil and gas fill the pore spaces in different proportion, and the relative permeability of one fluid in the rock is dependent on the amount of saturation and the nature of the other fluid. And if you consider the relative permeability, that will be less than the total sum of the relative permeability present in there, or to be specific, if I want to write, so suppose 3 gases, 3 liquids are there: water, petroleum, but not petroleum, water, petrol and gases are there. Okay. So if these 3 liquids are there, then 3 fluids, not liquids. If 3 fluids are there, then let's consider. So what will be the effective and the effective porosity of effective permeability of water, effective permeability of the petroleum, the effective or the petrol, effective permeability of gases will be less than the total one. Why? Because the interference of these 3 liquid basically reduces the total permeability, reduces the sum. Okay, the interferences of these 3 reduces the sum. So the capacity of the rock to conduct fluid presence of the other fluid is its effective permeability. For that particular fluid, it could be water, it could be gases. So there is an effective permeability for every fluid in the presence of the other. Okay, and sum of this effective permeability of each individual fluid is less than the total permeability. The interference basically reduces. So the sum total of the effective permeability of all these 3 is less than the absolute permeability of the rock, because the mutual interference reduces it. Okay. Now relation between the porosity and permeability. A permeable rock is always porous. There is a cases I did discuss also that a permeable rock is porous, but porous rock might not be permeable. That means if you taking 2 cases, case 1 and case 2, if there is a mineral grains or there is a grains which have a void spaces, and suppose the porosity for both the cases is same, permeability in this case let's say is K1, and here the interconnected porosity is not available. You see here porosity is same for both the cases. Okay, so what will happen here? And if the permeability here is K2, then you know that K1 is always K2, where phi, this is phi 1, phi 2, phi1 could be phi2, but k1 here in this case k1 will be greater than k2. So porosity could be same for both the rock sample, but permeability can be changed depending on the interconnectivity. So nowadays several artificial methods are used to increase the porosity and permeability of the reservoir rock. Some of these methods are explosion, excitation, hydraulic fracturing of reservoir rock. Hydraulic fracturing means creating an artificial fracture in the rock using water, and through the holes, porosity and permeability and the categorization of the common reservoir rocks can be also can be expressed, and it can be expressed in this way. Let's consider the porosity and permeability here, and then we'll be assessing that is good for reservoir or this rock is bad for reservoir. So last time I discussed it with only the porosity. That's not the right way to do it, because you have to consider the permeability also. So when you will be talking about porosity, you have to consider the permeability. Now let's consider the porosity percentage, okay, and let's consider the permeability in milliliters, and I'll be saying at this column that is this rock is good enough for reservoir or bad enough for reservoir. Suppose the porosity is 0 to 5. If the porosity is so much less, then the permeability will be negligible for obvious reason. So this is not good for your this side like assessment. So this rock is not good for your reservoir. This rock cannot be a reservoir. Now if some method, suppose there is other technique in geophysics, that's called the oil log, geophysical oil logging. There you can easily estimate the phi and k by indirect method. Okay, so if you get that the phi is 0 to 5 and the poro permeability is obviously negligible, then you will be seeing and saying that this rock is not good for any reservoir. 5 to 10, same, it's not it's negligible, so it's not good for reservoir, so you will be writing poor. 10 to 15, the millidarcy permeability could be in between 1 to 10. So if the porosity is 10 to 15, the permeability range will be within 1 to 10 and 1 to 10 millidarcy. I told you that in the rock we generally express the unit as millidarcy क्योंकि वही range पे आता है. Okay, so then I will be saying it's fair, but commercially might not possible. Now if you have the 15 to 20, then your rock permeability could be 10 to 100, it could be good. Now you have 20 to 25, so it could be 100 to 1000. See, if the porosity 20 to 25, then your permeability could be in the range of 100 to 1000. समझ रहे हो? मतलब इससे जो फेयर बोल रहे थे, इसका लोएस्ट वैल्यू ले लो और इसका हाईएस्ट वैल्यू ले लो, इससे 1000 times more interconnected spaces are there, so it will be the better. This will be the very good. Our objective is to find, or our objective is to explore such rock so that the porosity is in between 20 to 25 and the permeability is greater than 100. Then you will be going for some digging oil. Okay, so these are the two basic factors which defines which rock is good for reservoir, which rock is not good for reservoir. Now I'll be discussing on the types of the reservoir rocks. कोई क्वेश्चन है किसी का? Any question? So types of the reservoir rock. So reservoir rocks can be mainly classified as, mainly reservoir rocks are sedimentary rock. 90% of them are the sedimentary rock, or 95% of them are the sedimentary rock. So first one is the clastic. So if I ask about in the exam that write down the types of the reservoir rocks, so you have to explain all three. Okay. Second is your carbonate, and third, this classification you have already read. Third is your miscellaneous. So what do you mean by clastic sedimentary rock, and what is the example of clastic sedimentary rock? Tell me. Yes, how clastic sedimentary rocks are formed? Sediment. Yes, weathering of the primary rocks, and that's basically help you to deposit this clastic kind of rock. Okay, so and this carbonate rock falls under which type, which classification or the same? That's the example. Which classification carbonate rock आता है? किस क्लासिफिकेशन किस टाइप के अंदर आता है कार्बोनेट रॉक? Yes, non-plastic rock. It's a chemically formed rock. Then organically formed rock. Give me one example of organically formed rock, which is very useful for your energy class. Coal. Yes, yes. Who was telling? Rahul. Okay. Now for the clastic sedimentary rock, let me tell you the origin due to the that classical mechanism I discussed. That one mechanism I discussed in the beginning of the class, that the several grains are developed due to the it has, so classic rock in one word you can say is as a mechanical origin, means due to some weathering or due to some physical agents or due to some the effect of the water, air or glacier, these type of rocks are formed and small fragments are developed, no chemical reactions are involved here. So this is a clastic type of rock, and the example of clastic rock is, this is how clastic rocks are developed. And the example of plastic rock and different types I've already discussed कि क्या क्या टाइप होता है, एरेनेसियस होता है, क्या आर्जिलेसियस होता है, क्या क्या होता है. I've already discussed that part. So in case of plastic rock, maximum occurrence of oil and natural gas, if you see any, if you type in the internet or the Google, if you type for the petroleum reservoir or any cross section you are seeing, most of the cases you will be seeing this clastic rock, and the most famous one is your sandstone. I generally denote sandstone as SST, or people generally, geologists generally denote sandstone as SST. So the maximum occurrence of oil and natural gas and also productive accumulations are found in a clastic rock. So this is very much important. Okay, and the example of the clastic rocks are sandstone, siltstone, arcoges, and grey waki. I'll discuss what is arcos, what is grey waki. Last time I didn't discuss in that slide. Okay, so sandstone are very common. Sandstone in the ancient India or in the ancient days, people were using sandstone to build their houses. गांव में भी तुम देख सकते हो, if your house is near, if your house is in राजस्थान and all, नहीं तो most of the time जो राजस्थान का फोर्ट है, जो लाल किला है, it's basically made up of Indian sandstone. And if you know pyramids in Egypt, pyramids or the faces of the pyramids, okay, जो फिनिशिंग देता है ना लास्ट में, सिविल वाला ज़्यादा बोल पाएगा. So the pyramids are basically made up of limestone. So most of the pyramid or the Giza pyramid, you have heard of it. So that pyramid is built up of limestone. वो तो चला गया तो ऐसे real life example. But so sandstone is very vertically and laterally in texture, composition and thickness and forming lenses. So I'm talking about the clastic one. So sandstone, not only you will be finding the main constituent sand, you will have the other components as well, like shells. Okay, you will be seeing some silt there or some siltstone is there. So the sandstone may be shelly or siltstone, it is interpreted with the shell. The sand lenses may be full of oil and gases and may form several pools extending over a large area under trap condition. So under trap condition, and another thing you have learned, that lenses. So within the sandstone, okay, or the sandstone could be a good reservoir. So let's remember this thing for your next class. I'll be discussing when I'll be discussing the trap and all. There I'll be, or the structure of any reservoir. There I'll discuss what is a trap and what do I mean by sandstone lenses. So when I'll be discussing the migration of oil and gases, there I'll be discussing details. So as for now, try to remember that. So let me give you a hint. That's the, let's say, anticline. So what happened? let me give you a very brief idea. Suppose the upper layer is impermeable. Okay, this is our anticlinal structure, folded structure. Remember, this layer is also impermeable, and in between them you have the sandstone. So petroleum will migrate, and it may be stored here in this position. And the zone I am showing here is, it may look like it's a very narrow chain, कितना ही petroleum रहेगा, लेकिन consider it's a consider the area of few 100 square kilometer. Okay, so in this sandstone generally this thing will be accumulated, and this is called the this has another name. This reservoir is called the trap. It's trapping the hydrocarbon, it's trapping the petroleum, and this portion is called the cap. So I'll discuss this in your next class कि कैप क्या होता है, ट्रैप क्या होता है, कैसे कैसे होता है, कैसे माइग्रेट करता है. So as for now, you should understand the lateral variation in the mineral composition and the texture of the sandstone may reduce its permeability and it may become impermeable. So अब यहाँ से तो आया है पेट्रोलियम, इधर से तो निकल भी सकता है, but what happened here in the trap condition, in a hydrocarbon trap condition, the lateral variation in the mineral pools extending over large area, okay, and sometimes the porosity and the permeability here will be reduced due to some compaction. So porosity will be reduced, permeability will be reduced, so that अभी तो आया इधर से है लेकिन जा नहीं पाएगा. इट्स ए सिंपल डायग्राम, इतना इजी भी नहीं होता है. ओके, समझ रहे हो? सो ये इसको ट्रैप कर लेता है हाइड्रोकार्बन के, एंड देन यू विल हैव योर रिजर्वर रेडी. Okay, conglomerates and grades consist of large particle, mostly silica and silicates than sandstone. These are the common. I will suggest you to go through that PPT I have forwarded. Okay, so वो PPT के एक बार पढ़ लेना अच्छे से, तो तुमको मालूम चल जाएगा what is conglomerate, what is breccia. I have already discussed but go through that PPT, read the study material, then you will understand this geological term. So these common reservoir rocks form lenticular bodies enclosed by fine-grained rock or similar or more uniform composition. Sometimes you will be saying the trap like this also. Okay, this type of shape is called the lenticular shape. Now under the clastic sediment, clastic reservoir rocks, there is another type. Sandstone is the most famous one. It's good for the petroleum reservoir. And the type of rocks are there, that is called the grey wakis. So grey wakis are the particles ranging size from mud to sand and consist of quartz, feldspar, silicates and rock fragments. So grey wakis are that particles which ranging the size from clay. I have already classified कि clay का क्या size होता है, less than 1 to 56 millimeter diameter. Remember? So the size of that grey waki is clay to sand, and it consists of generally quartz, feldspar, okay, and silicates. Plus rock fragments. Non-feldspathic grey wakis from excellent reservoir rocks. Sometimes you will find the grey waki reservoir rocks in USA side, and it's a non-feldspathic grey waki from excellent reservoir rocks. Another type of reservoir rock is arpos. So arpos is with mixture of quartz and mica. It's a mixture of quartz plus mica. Quartz is ये तो पूछा ही नहीं मैंने, बताओ quartz क्या है? Quartz क्या है? What is quartz? No, quartz is a mineral. It's a mineral. It's a mineral. Quartz is a mineral. It's a most found minerals in nature. Quartz and K feldspar. Potash feldspar is the most available mineral in nature. 96-7% of total minerals you will find quartz there. कोई भी पत्थर उठा के देखो, सादा सादा मतलब व्हाइट सा जो शाइनी पार्ट रहेगा ना, उसको क्वार्ट्ज बोलते हैं. मोस्ट ऑफ द केसेस, नॉट ऐसे क्वार्ट्ज को एक्सप्लेन नहीं कर सकते. एंड माइका, यू नो in your road works, if you ever seen, गांव के साइड में जिसका घर है उसको मालूम हो सकता है कि माइका क्या है. जो रोड वर्क में वो लेटराइट रेड कलर की जो सॉइल कवर डालते हैं, उसमें जो थोड़ा सा फ्लेकी स्ट्रक्चर रहता है, जिसमें ओनियन टाइप का स्ट्रक्चर रहता है, उसको माइका बोलता है. ऑलरेडी डिस्कस इन द फर्स्ट क्लास. भूल गए तो पहले एक बार जाके उस क्लास का वीडियो देख लो, ठीक है ना. Now for the arkose is basically mixture of quartz and mica and free from clays. So there will be no clay particle there. And weather debris are the important reservoir rocks in many parts of the world. However, many arkoses become impermeable with weather fragments. Another important one is the siltstone. So tell me the diameter or the size, grain size of a silt. Grain size of silt in between which two? No, tell me, it's greater than clay or less than clay, what? Yes, it's sand, in between sand and clay. So sand, silt, clay, ऐसे याद रखना, से sand, silt, clay आता है. Okay. So siltstone, which has a size is, the grain size is less than sand, and fine particle comparatively have too low primary permeability. So the particle grain size decreases, so the what will be decreasing? Permeability will be decreasing. Yes. So because of this, you will have, and these are not, so commercially there are no accumulation. It could be a reservoir rock, but I have to check, or I will considering that rock which give me some profit. I'm investing some money, a huge amount of money to extract oil, और मुझे देखना है कि कितना amount है. So that the if permeability lays in the siltstone, and I'm talking about the, I'm not considering the secondary permeability developed later, but I'm considering the, let's say, the total permeability in general sense is less. Okay. So siltstone consists of comparatively fine particles and have low permeability, primary permeability, to be satisfactory reservoir rocks. So there are commercial accumulations in some siltstone which have been affected by the fracturing. Okay. Now most clays occur most of the reservoir rocks in varying proportion. Clays influence the porosity and permeability. Clay क्या करता है ना, basically it decreases the porosity and permeability of the rocks. It acts as an impermeable layer. It acts as an impermeable layer. So if you have, if you are familiar with clay and all, like there is a clay type that's called the bentonite. Okay. Geography book में तुम पढ़े होगे what is bentonite. And bentonite used to, गांव के साइड में क्या होता है, अगर कहीं पे सपोज एक गड्ढा खोदा गया है, सपोज, एंड दे डोंट वांट टू, एंड दे आर प्लानिंग टू स्टोर वाटर हियर, सो दे क्या करते हैं, यहाँ पे एक बेंटोनाइट का लेयर दे देते हैं, सो दैट द वाटर विल नॉट बी पासिंग थ्रू दिस. थोड़ा सा लीकेज, थोड़ा बहुत लीकेज होगा, बट मोस्ट ऑफ द वाटर विल बी इन देयर. So that's why bentonite is used. So clay basically act as an impermeable layer, and if the presence or percentage of the clay in nature, you won't find most of the cases that okay, it's a totally sandstone is there. There is not. Sandstone could be of shelly sandstone or silty sandstone, or the sand, you will be the loose sediments, you will be saying shelly sand or clay sand or silty sand. Now depending on the percentage of clay, depending on the percentage of silt, you can classify it's a clayey one or it's a silty one, but not seeing pure sand is, or pure sandstone is not possible. Some impurities will be there, वो तो होता ही है, नेचर में कोई चीज़ परफेक्ट नहीं. So what happens if clay percentage increases, the permeability decreases. If clay percentage is higher, I was talking about the geophysical oil logging, and there we generally determine the cell percentage. Cell means clay, which determines the cell percentage and the volume. So phi cell by phi, we generally use several method, like the electrical method is there, the resistivity method is there, cell potential method is there. Okay, by applying the physics law, we are getting, or we are having an idea how much, what is the cell percentage here. So by understanding or by determining that, it's a key factor to it can, ये काम बिगाड़ सकता है, ये काम सही कर सकता है. Okay, So the clay occur in the most of the reservoir rocks in varying proportion. The clay influence the porosity and permeability of the reservoir rocks, and therefore greatly influence the oil and gas production in several oil fields. So shale mostly composed of clays form reservoir rocks in the some area, probably due to the fracture in it. Now for the non-clastic rock, the carbonate reservoir rock is also there. So I have told you in the beginning, I am repeating this again, let's think down, that sandstone and limestone are the constituent rock, are the main rock or the chief rock for 90% of the reservoir. 90% of the cases you will find sandstone and limestone. Sandstone or limestone, okay? Now for the carbonate reservoir rock, if you could remember that we are talking about the type of the reservoir rock. So for the carbonate reservoir rock, what happened? The carbonate reservoir rocks consist of the mixture of varying proportion of calcite, limestone and dolomite. Calcite, limestone, which has a key constituent calcium carbonate, right? Dolomite. Limestone का key constituent क्या है? Calcium carbonate. Yes, dolomite is the magnesium carbonate. Okay? मैं शायद इसका ये मैग्नीशियम कार्बोनेट Mg2CO ना MgCO3 होता है सिंपली. ओके, सो कैल्शियम कार्बोनेट एंड मैग्नीशियम कार्बोनेट. लाइमस्टोन को क्या बोलते हैं हम लोग इन आवर डेली लाइफ? व्हाट वी कॉल लाइमस्टोन? चूना पत्थर. चूना पत्थर बोलते हैं ना इसको. इसे जो लोग पान खाते हैं उससे वो जो चूना लगाते हैं ना, वो वाला चूना निकलता है यहाँ से लाइमस्टोन से मोस्टली. ओके, एंड लाइमस्टोन मेटामॉर्फिज्म के बाद क्या बनता है? एनीवन? डज एनीवन रिमेंबर लाइमस्टोन मेटामॉर्फिज्म के बाद क्या ट्रांसफॉर्म होकर क्या बनता है? आफ्टर मेटामॉर्फिज्म मार्बल बनता है. यस, ओके, तब ठीक है. सो कैल्शियम द मेन these are the carbonate rocks. Okay, so main constituent is calcium and magnesium, the main elements, and these are either formed by biochemically or precipitation from the solution. So the carbonate rocks are mostly mixed with sedimentary materials, and it may form by biochemically or mostly by the chemical precipitation. So the carbonate rocks are mostly mixed with the sedimentary materials in different proportion to forming a large variety of impure carbonate rocks, like shelly carbonate rock could be there. So clay plus limestone could be of shelly limestone, or a sand plus limestone could be there, sandy limestone. ऐसे नाम होता है पत्थरों का, ठीक है ना. अगर सैंड का परसेंटेज ज़्यादा रहता है देन क्ले. सैंड प्लस लाइमस्टोन मीन्स इसमें क्ले भी रहता है. ओके, और क्ले प्लस लाइमस्टोन मीन्स इसमें सैंड भी रहता है most of the cases. Okay, and if the clay percentage is higher, then I will be saying it's a shelly means clay. Okay, and if the sand percentage is higher, the comparing to other impurity that is clay, then we'll call it generally it's a sandy limestone. So next to the calcite rock, limestone and dolomites are most important reservoir rocks, containing about 1/3 of the petroleum reservoir. 1/3 of the petroleum reservoir is made up of sandstone limestone. So 60% is for built up by sandstone, 30% or 33% or 35%, let's say, or 30% built up by limestone. Okay, so in comparison to the sandstone, what happened here, the reservoir properties of the carbonate rocks are much more affected by the fracture. The limestone or this carbonate has a property or tendency that it reacts with water, which was not present in sandstone case, in the clastic rock case. So what will happen here? So most of the cases the porosity actually will be the secondary porosity, and they are also affected by the secondary porosity. Means it could be the fracture, it could be the vugs, it could be the some holes found by some chemical reaction. Okay, so many large oil fields are found in contain carbonates which have high fracture permeability. Unfractured carbonate rocks comparatively form poor reservoir. So कार्बोनेट रॉक का क्या है ना, अगर फ्रैक्चर्ड ही है, इफ इट्स फ्रैक्चर्ड then it's good enough, unfractured is not good enough. Okay, so the maximum concentration of oil and gas in the carbonated rocks is found in the Middle East, mostly Iran, Iraq, Kuwait and Saudi Arabia, जहाँ पे mostly तेल का कुआं है. So in this area what you are finding or the rock or reservoir type is mostly carbonate one, and this carbonate rock if it's fractured it's good for reservoir. Okay, in the Middle East you will find this type of rock for or to become a reservoir. Now let's talk about the other reservoir rock, that is our third type. If you remember that I was discussing about the type of the reservoir, so other which are other options, I have already covered the sedimentary type. So other options are igneous and metamorphic. So igneous rock and metamorphic rocks are also could be of reservoir if you know that igneous and metamorphic, what is the characteristics in terms of porosity and permeability. Tell me what is the characteristics of igneous and metamorphic rocks in terms of porosity and permeability. What happened, what are the porosity and permeability range of igneous and metamorphic rock? This igneous and metamorphic rock, the porosity, permeability or the volume of the void space is very less, because metamorphic is a very compact rock. In the igneous rock you will be seeing some vesicular structures in the basalt, or that vesicular structure generally might not be interconnected most of the cases. So you will be seeing that in these cases porosity and permeability are generally less, but for some reason, some earthquake activity, some physical processes, what happened, there are secondary fractures. So you will be saying this is a really reservoir. These rocks really have commercial accumulation, generally don't use for we are not considering these rocks or this rock type for reservoir. And the oil migrator from source rock usually occurs in fracture of the rocks and the occurrence of the, so if there is secondary porosity or the fracture mostly, or the any faulted displacement is there and and the surrounding is the impermeable rock, and somehow the oil reaches there and due to the impermeable rock in the surrounding is not going anywhere, then only you might have some structure, which is very rare, and these things are not considered for our sources. So commercial occurrences have been found in basal intrusive and flows and at some places. Okay, so at some places in basalt, because it's a vesicular structure, you will be seeing. So basalt में कुछ जगह पे दिखा है, but people are not digging it commercially most of the time, or not taking this seriously most of the time. So these are the three classifications of the reservoir rock. In your next class, that's tomorrow, I'll be talking